everyone, welcome to the second video on finding extrema of a function. So in the first video, we talked about how to find relative extrema. And remember that relative extrema are restricted to a specific interval of the graph. So in this video, we will talk about the first way to find absolute extrema using the first derivative test. So remember that absolute extrema do not restrict to a specific part of the graph, but they look at the entire graph. So we're going to just immediately come down to example 2. So if you missed example 1, you can go back and find that video. So we're finding the absolute extrema of a function, and this question specifically tells us to use the first derivative test. So keep in mind, your question may or may not tell you to use the first or second derivative test, and if that's the case, you can use either. So the first step to find the extrema of a function, no matter if you're finding relative or absolute, is always to find the critical points of the function by solving for when that derivative is equal to 0. So if my original function is x to the 4th minus 2x squared plus 3, then I just take my derivative term by term using the power rule. Next, I set my derivative equal to 0. And what I'm going to do is I'm going to factor this to find when this derivative is equal to 0. So remember that our first step whenever we factor is always to check if there's a common factor. And in this case, we see that both of these terms have a 4 and an x in common. So we're left with 4x times x squared minus 1. Then we remember that x squared minus 1 is a difference of squares, so it factors as x minus 1 and x plus 1. At this point, we are going to apply what's called the zero product property, but all that means is that we set each term that multiplies to equal to 0, and that's an option for us. So now that we have these three equations, we solve them each separately. So we have x equals 0, x equals 1, and x equals negative 1. So these are going to be our three critical points. Now, I'm going to point out something that we want to make sure we avoid. So this is something we do not want to do. So some people, whenever they see this expression, 4x cubed minus 4x equals 0, their inclination may be to add 4x to both sides. And then we see, okay, I can now divide by 4x on both sides because that's in common to both. And then that just leaves us with an x squared equal to 1. And taking the square root of both sides gives us x equals plus and minus 1. And we see that, okay, it gives us two of the answers that we had over here in the black on the left. So what this does is we never want to divide by x. So if your inclination tells you to separate these terms and then divide by the common terms, that's not what we want to do because we're dividing by 4x and that gets rid of the potential solution, x equals 0. So instead, what we want to do, if we see that there's something in common, we want to factor it out on the same side of the equal sign and not divide. Okay, so now that we have our critical points, what we do is we plot our critical points on the number line. So we have negative 1, 0, 1. We plot these points on the number line and we find test values between each critical point. So here I am going to have the point 1/2. Here I'm going to have the point negative 1/2. And then we also need to find points on the other side of the 1 and negative 1. So I'm just going to pick negative 2 and 2. So these may have been what you wanted to choose. They may not have been. And it's fine if you want to choose something different. The only thing that we need to remember is that they just have to be between but not equal to these values. So next, we're going to evaluate the derivative at each test value to determine where the function is increasing or decreasing. So one thing to notice here is that if we are finding the absolute extrema using the first derivative test, that means we are evaluating the derivative at these values, not the original function. So we're finding the derivative at negative 2, first of all. So remember our derivative is 4x cubed minus 4x. So I have 4 times negative 2 cubed minus 4 times negative 2, which is going to give me 4 times negative 8 minus 8. So you can expand this all the way out to find that we have, sorry, that should be a plus 8, that we have negative 32 plus 8, which is negative 24. But the main thing is that we know if this is positive or negative. That is the main thing here. So if your instructor has told you to simplify this all the way out, you can find the exact value, or as soon as you know if it's going to be positive and negative, that is all we need to know to apply this test. So next, we're going to evaluate the derivative at negative 1/2, which is going to be 4 times negative 1/2 cubed minus 4 times negative 1/2, which is going to be 4 times negative 1/8 plus 4 times 1/2 is this is half. And solved, you can see that this is going to be positive 3/2, which is greater than 0. And we just finish this out. So we can evaluate the derivative at 1/2, which is going to be 4 times 1/2 cubed minus 4 times 1/2, which is going to be 4 times positive 1/8 plus 2, which is going to be 1/2, minus 2, which is going to be negative 3/2, which is less than 0. And lastly, we evaluate the derivative at positive 2, which is 4 times 2 cubed minus 4 times 2, which is going to be 4 times 8 minus 8, which is 32 minus 8, which is positive 24, which is greater than 0. Okay, so like I said, the important part here is when is this function greater than or less than 0? So what we're going to do is we are going to redraw this number line that we had before and redraw our test points. And we're going to use where this function is increasing and decreasing to find out where our extrema are. So remember, if my derivative is positive, then my function is increasing. And if my derivative is negative, then my function is decreasing. So if you forget why this is true, just remember that a derivative represents a slope. And if our slope is positive, the function's going up. And if our slope is negative, the function's going down. So on this number line on the new page, I'm just going to trace what's happening. So my function is decreasing and then increasing and then decreasing and then increasing. So this gives us an idea of what that graph is going to look like. So we know that we can see that here, it looks like the function goes something like this. So this can tell us where our maximums and minimums are. So first off, we can see where does the function change from increasing to decreasing. So the function changes from increasing to decreasing at x equals 0. So that's going to tell me that this is a maximum. And you can see in the way that we drew this, it does look like we have a maximum at x equals 0. Next, the function changes from decreasing to increasing at x equals 1 and negative 1. So these are minimums. And again, in the way that we've traced this graph, you can see that it looks like there are minimums here and a maximum here based on where these hills and valleys happen. And part C says, is there any critical point where the function stays decreasing or stays increasing? So there's no point there. So you don't necessarily need to write a conclusion for part C if that case doesn't occur. So this is how you use the first derivative test. So first, we always start with finding our critical points. We plot those points on a number line, find values in between them, and then we draw this picture. This is called a sign chart. And we draw this sign chart to kind of help us figure out, okay, is my function increasing or decreasing, and get a rough sketch of what that function is going to look like to help us identify where do we have the hills and the valleys that tell us where we have minimums and maximums. So this is all we're going to do for this video, is talk about using the first derivative test. Next, you can find videos for our using the second derivative test and finding relative extrema, where you found this one. But we hope that this helps, and good luck.